Hi, my name is Tim, and this is a tutorial on the JavaScript function. This is a introduction video, and I'm going to be talking about the function, the major components of a function, what it takes to create one. So this is not a deep dive, it's just a top surface tutorial, but let's jump in. So when you create a function in JavaScript, you're creating an object. Okay, and objects are very, very important because everything, one of the main constructs in the JavaScript language is an object. And almost everything is an object except for primitives. And primitives, there are 7 of them. They are undefined, null, boolean, number, string, the big int, and the symbol. And I'm not going to read this off. You can stop the video if you like and take a look at this and read it to get a quick understanding. A first look at these definitions right here that I put down for primitives. I will point out that primitives, they do not have any methods and they are immutable, meaning they can't be altered. So with that being said, the anatomy of a function. So we have a keyword, which is function. When we create a function, we have to use this keyword function. As you notice, it has a small f. And people who are just starting out in the language, they will also find another exact word function, but it will have a capital F. This is a parent object. This is a built-in native code that's in the JavaScript language. It has this object here, this word function. It is a parent object, and it has methods and properties within it. So these properties and methods in this function, when you create a function, your newly created function actually can inherit the properties and methods on this function. And it does that by using a prototype property on the objects. So this function that you create has a prototype property on it. This function has a prototype property on it. Almost every object in JavaScript, except for primitives, have a prototype property on them. And that's very important. You want to might want to take a look at that and read up about it because it's really important to understand that at a later time. So we have a keyword function. We have after the keyword function there is a name, or you can have a name or not have a name. And anonymous functions are only you can use anonymous functions and function expressions. This is the only place that you can use an anonymous function. And again, when I say anonymous function, I mean a function that doesn't have a name. And as an example, here in this function expression, we have a function right here. This is the keyword. There is no name right here. So this is an anonymous function right here. There is no name. And what we're doing is we're creating this anonymous function and we're assigning it to this variable foo. So that is what we mean by anonymous function. Then we have the parentheses in the function declaration. And those parentheses do not have to have parameters and the number of parameters. You can put a lot of parameters in a function depending on what you're trying to do. And those parameters are basically comma separated, either an X, comma Y, comma Z, comma D, comma whatever. You can put a primitive up here. You can pass in primitives. You can pass in numbers. You can pass in other objects. Then we have the function body. The function body is everything between the curly brackets. What I mean by that is we have here, this is a function, this is what we call syntax, meaning that this is pseudocode. We're saying, okay, here's the keyword function. Then we put any kind of function name you put right here after the keyword function. Then inside parentheses, you put your parameters in here. And then you have a open curly bracket and a closing curly bracket. This is the body of the function. And then you have your code inside. And as you see, you can put any statement here with a semicolon. And then the next line inside this function body, you have another statement and another statement. And this is what we call the function declaration syntax. Now here is an actual function down here. We have the keyword function. We have the name, add nums. We have parentheses and a comma separated parameters x and y. We have an open curly bracket and a closing curly bracket. And then we have a single statement. Here's a statement here. This is a statement. Return x plus y. And that is the function, kind of a function syntax. Then down here, again, we have a repeat of that, just to let you know that when the JavaScript engine, when it comes down, and again, JavaScript is a synchronous program. It basically does one thing at a time. It runs code line by line. So in essence, what it does is it starts up here at line 1 and reads line 2, then 3, then 4, then 5, then 6, then 7. And just very basically, if the JavaScript engine, the interpreter, comes down to line 1 and then looks over here, it sees these 2 forward slashes, and it knows to interpret whatever's on this line as a comment. Is not in the program. It's just a comment for the user to read. And then it says, okay, come down to line 2, because I'm single threaded. I do one thing at a time. And then it reads the keyword function, and it says, oh, so all right, there's a function. What's to follow is going to be a function name, and you're defining an object. So here is the name of the object. So it takes this, and then it has, it says keyword function, here's my name, here's my parentheses, and then I have some parameters in here. The interpreter takes all this information right here, just this information, this one line right here. This is the function declaration. It puts this name in its global memory. So it puts it in, it puts it in memory. And so that it can actually use this name to point to what it's going to put all this also in memory, the definition. So it uses the name to actually reference this definition. It doesn't execute this. The only thing the interpreter is going to do on the first time that it reads this code, it's just putting all this information in. It allocates or creates a area in its machine level memory. So it's going to put this name in a location in memory. It's going to put this definition in a location in memory, so that when you reference this function name later on, it's going to be able, this is an object, right? So it's going to be able to reference the definition of this object. So with that being said, I don't want to get into that anymore. So let's just pretend that this colored, kind of a pinkish, I don't know what color that is, but when the JavaScript engine reads this function and this name here and puts it in memory, it does that. Once it comes down, and let me show you this example again. Once it comes down to this, say this function here, and then this add nums, if I were to call that function, for instance, this is my function, let foo equal function, and I have x, and then return x times x. Now, if I call this function, I call it with the word, the function identifier, which is foo, and then I'm going to pass in an argument. An argument is 2, it's a number 2. So this is a function call. This foo with the function call here, in the function call foo with the open and close parentheses and 2, what happens is, again, the JavaScript engine is reading the code down this column, the single thread, and then it reads this, it puts this in the memory, but then all of a sudden it comes down here, further down the code, it reads this foo with parentheses, and then it has an argument, the argument is 2. It executes this, it goes and it looks for foo. So it knows that at this point in time, it wants to execute this code. So it goes and it looks for the identifier, the function identifier foo. It finds foo in memory, right, that we just talked about. And then it references the definition. And so it pulls in the definition, and then the interpreter actually jumps inside that body and it starts to execute what from left to right, what this is. So we have a statement return, and it says, okay, you want to return whatever's on the right. And so we have this evaluation here, which is x times x, and I'm passing in 2 to x here, or to this right here. I'm passing in 2 to the parameter. So this is your argument. Your argument is a number, and the value is 2. I'm passing it by value into the x, and in and then the 2 is then in the body. It's passed to the value 2 is passed into this x, and also is passed into this x. So now we have 2 times 2, and when it gets evaluated, the result is 4. So 4 gets returned at the end of the function call, at the execution. The 4 gets returned to the interpreter, and so your result is 4. And so however the return basically exits this keyword return. Basically, once this is completed over on the right, this evaluation, this return is going to exit this function call, and this execution here, because every time that the interpreter, not you, but the interpreter, every time the interpreter executes a function, it actually creates what we call a function execution context. It basically says, okay, everybody stop. I'm going over here. I'm going to create this function execution context. Basically, it's a box, and that's what I mean here. Let's pretend that this is the function execution context here. The interpreter has created this all by itself. This function is going to just sit there all alone, and it's going to be in its isolated little function execution context or environment. And the interpreter is only going to work on this stuff right here. It's just going to work on this stuff. It's not going to work on anything. And it won't do anything else until it completes this. So you now have this word function. My function actually gets put on as the interpreter is working on this. It needs to know, like, hey, what are you doing right now? So what it does is it takes the name, and this name right here, the function name, gets put on what we call a call stack. Basically, pretend that like the call stack is a column, and like you took a bunch of dominoes and you stacked them from the bottom up, and we have a stack of dominoes. Well, in the same analogy, we have this is our first function that the interpreter runs into. So it's created this function execution context, where the interpreter is just going to work on this stuff right here. It's not going to do anything else in your program. It's got this environment. It's going to work on this, and until this is completed, that's all it's going to do. Now, this is a synchronous program that we're running here. Again, things are being done line by line, and the JavaScript engine reads everything line by line. So in this context, if it were to read another function, it actually would create another environment just like this. It would keep this on hold, create another environment, and then it would jump into that environment and execute that environment until that was done. And then it would come back to this one. And then when this one is done, then it would jump back into the regular code and keep executing it. So I hope I didn't lose you there. What we have then is a function currently that's being worked on. We have a function execution context. We have my func is put on the call stack, and it stays there until this is completed. When this function is completed by the interpreter and we've returned our value, which on the right, the evaluation x times y, and when this is finished and resulted, then the interpreter exits this function. We get rid of the function. This my func name gets popped off all the call stack, and then the interpreter, the JavaScript engine, just goes back where you are in your code and just keeps running down and goes to the next line. So I know that was a little aside there, but excuse me, and I just kind of want to explain that. So the next important thing I want to explain is the function call. And the function call is invoked by the name of the function, which is my func, and also the parentheses. So we have a function call right here, and this is the name of the function, and we have parentheses. Parentheses, you need the parentheses in order to call the function. If you don't have parentheses, then you're not going to be able to call the function, and then you're going to be looking at something that's just going to be like, well, wait a minute, that's just the definition of my function. And I'll show you here that in a second. So this is your function name. This parentheses, which you need when you call a function, and in the definition of a function call, parentheses are necessary. And then these are arguments. You can pass in a number, a string. You can pass in another object, which could be a function. For instance, a callback function. But I have here two arguments. So I have the number 2, a comma, and a 2. And the 2 is going to be passed to the x. And the argument by value is passed into the parameter x. The argument 2 by value is passed into y. And so x gets passed into the body of the function. The x gets passed into x, or the 2, which the interpreter basically has assigned x equals 2, y equals 2. And so this x gets 2, this y gets 2. When the interpreter reads this line, it says, okay, return this equation over here, evaluate this, 2 times 2 equals 4. And then the function here, this keyword return, it's also known as a statement, will return the completed value, which is 4, and then it exits. This also exits the program. The word return will exit the program, and then you're out of, again, the function. So again, this function execution context or environment goes away. The myfunc gets popped off the call stack, and you continue on down in the progress of your application. So let's take a look at a couple functions here that I've written out. So again, this is an example of a function declaration, meaning that we use the keyword function. I have the name is foo. I have my parameters there, and which are x and y, and then I am returning in the body the product of x and y, and then down here I'm going to call the function. Because I'm only returning it up inside the body, to take a look at it here, what I need to do is I need to console log it to the console. I need to log it to the console, so I'm using the log method down here in order to log it out, so you can take a look at it. So when I run this code, you'll see 20, because what we're doing is we are down here in the call. We have our 2 arguments, and we have a number here, and these are primitives, 4 and 5. They're numbers, so they're primitives, and they're comma separated, which is really important also. So the value 4 is passed by value into x, and then 5 is passed by value, which is 5, into y. And then the interpreter steps into the body, and then it returns 4 times 5, which is 20, and it returns the value of 20. And then when we console log, we get the answer, which is 20, and that's what you see down here in the console. So let's go to the next function. So again, that was a function declaration. I'm going to just comment that out, and here is a function expression that I previously wrote up, and I did this so you don't have to hear all my clicking. In a video, sometimes that gets a little annoying. So here we have, we're using let, and this is your variable. So we're assigning a variable with the name myfoo. They have an assignment operator, so when the interpreter, JavaScript engine comes down to this. It says, okay, I see the assignment operator, and so you're going to assign something on the right to the variable my foo, and you're going to place it in memory. And what's on the right is a function, and there is no name, so that's a anonymous function, and it has a parameter which is accepting a single argument. And so down here in the log method, it's logging out a string, and I'm using literal notation, string literal notation, meaning that I have a backtick here and I have a backtick here. And then in order to reference this y value up here, I use the $sign and then curly brackets, and then I place the y in between the curly brackets, which is going to reference the value that was passed in. And then down here, I am calling the function my foo, and I'm putting in my argument 4. So this should actually say this is the passed in arg value, and then that should be 4. So let's take a look at it. And it says this is the passed in arg value, and the value is 4. So let's close that out. And again, that's a function expression. Then down here is a quick example of a iffy, a immediately invoked function expression. And let me get rid of these comments. That one I still need. And let's separate this a little bit. So here we have, so right here, this is a immediately invoked function expression. And it is that because, so we have an anonymous function here, and same thing up on top, right? But the thing is, we have a parenthesis, an open parenthesis here, and then we have a closing parenthesis here. So what I've done is I've wrapped this whole function, the function, anonymous function and its body, including the open and curly brackets within these two parentheses. And then what I've done is I've taken another set of parentheses, and instead of like down here writing something like, okay, anonymous function, the call, like the call down here, I'm actually calling the function immediately right here. So this is the value 20 that's going to be passed in to X, and then I'm going to basically do the same thing as before. So what I'm doing is I'm going to save this, make sure everything is there. I'm going to run this, and let's clean this up a little bit, and just so we should see 20. So now it says logging into the console 20. And this is, again, what we call an immediately invoked function execution. And sometimes when you're in an application or a program where you have a lot of files that are pulled in, JavaScript files, and let's just say that the word Bob was used in multiple occurrences within the code, then you could put Bob in here, and Bob would basically be scoped just to this function. It would not pollute the environment. You could still reuse like a variable. If you had a variable name in here, but it was used somewhere else in your code, then you wouldn't pollute the code. It wouldn't be, you've isolated it or basically encapsulated it in this pattern here, this iffy pattern. And so you've hidden it. So it's scoped in the context, in this lexical environment here. So let's close this, comment that out. And then down here, let's uncomment this guy. And this is our last function we'll take a look at here in this tutorial. So here what I have is a nested function. So I have an outer function, which is Q, and this is my function declaration here. And then, as you can see, I have an open and curly bracket. This is the open, and this is the closing down here, curly bracket for this function here. And then within the function, I've declared a variable y, and I've assigned it the numerical value of 4. And again, when I use let, it's scoping this y, this variable, just to the outer function here. Anything on the outside won't be able to see this. So it is scoped locally to this outer function. And so then down here, I have another function, and the function is, it's a function declaration. The name is multi, and then it's taking a, just like the function up here, is taking a single parameter, which is x. And then down here in the inner function, I'm actually returning the x, and x times y. And so because this y here was declared and instantiated inside the outer function, this inner function is going to have access. This is a closure. This right here, this is a closure. And so, but this function will be able to find the value of x. It will be able to look up the prototype chain, and it will be able to find the y inside this cube function. So it's going to have access. This function is going to have access to this y here, and this function is also going to have access to the x. So down here inside, so you've got your outer function, your inner function, or what they call a nested function, and then I have this statement right here, and this statement is a part of the outer function. So you finish, the interpreter is going to finish executing this. It's going to return the value, and then down here in the outer function, you're actually going to return, and you're calling this multi function, and you're calling it twice, and you're adding it. So you should actually see the value up here, the output is 16, and so here you should see 16 plus 16. 16 plus 16 should be 32. And then you're going to call cube, and you're passing in one number argument, and it's an x. And you're going to pass that numerical value here in your argument, which is 2. You're going to pass it by value again into the parameter x. So x is going to equal 2. And so down here, when we execute this, you're going to see the output is going to be 32. But one thing I wanted to explain is that you also see up here is that I have created another variable, but this is in the global scope. It's outside the outer function. And this let y equals 10. So this is outside this y here that was declared in the inner function. Okay, so this y is scoped only to this outer function right here. And the inner function actually has, can inherit or access this. Okay. So then down here, so up here I have let y equals 10, and in here I have let y equals 4. When I run my code for cube 2, it pulls in the y value of 4 into here. However, when the interpreter comes down and reads 31, finishes there, goes to 32, and then goes to 33, and then it goes, log y. And then it goes and it looks for this y in memory. Well, it finds the y10. It doesn't find the y in here because this y is only scoped or can be only seen within this function when this function is called, this outer function. So it's going to log the y, which is in the global scope. Anybody can see this. So it's going to return 10. So I'm in my Chrome Developer Tools. I'm in the Sources tab. And if you really want to get a closer look at like how the interpreter, this is a little bit off topic, but let's just take this very basic function here. You can go into the interpreter, go to Sources, go into this file, hit, these are basically breakpoints. So in this column here, just hit 2. When you see this highlighted, means the breakpoint, you set a breakpoint. It means it's on. And so then once you do that, what you want to do is you want to go up into your browser and you want to hit the reload. You want to hit the reload the page. And so what it's just done is your JavaScript engine has actually read your code, and it's put this information already in memory. Like I explained earlier, it's put the foo, the function definition or the name or the identifier. It's put that in memory. It's put everything here in memory. And so it's come down, it's read line 1, 2, 3, and then on line 5, it's read the word foo and knows that also it's read the parentheses and the 2, 2. So it knows that you want to call foo. So it's going to go look for foo, and it's going to find foo in memory. When it finds foo in memory, it's going to jump into the definition. It's going to execute it. So you're seeing right now this highlighted green bar. So the next thing you're going to see is the green bar is going to be right here, because like I explained before, the first time that JavaScript interprets your code, again, it's going line 1, line 2, line 3, line 4. It's synchronous. It's line by line. It reads code line by line. So when it gets to this first line up here, the first time around, it's just putting all this in memory, this whole thing in memory. Then as it reads 3 and then 4 and then 5, when it reads this line 5, then that's what it's doing. It's reading this line 5 right here. And if I step in, so when I click this down here, I've stopped the interpreter. I've stopped the engine. But when I step back into it, I'm going to say, okay, interpreter, take the next step. So I click, and like I said before, look what it's done. It's taken these arguments, and it's passed these arguments by value into the X and into the Y. So X gets 2, Y gets 2. And then it is stepping into the code. So it is down here in console log X times Y. And if I step again, then it is evaluated. As you can see, let me show you down here. So this is the local scope, meaning the execution scope of the function. So when we go into the function execution, it is creating a local scope for that. So 2 is assigned to X. And so basically this is a property X, property Y, and this property is assigned the value of 2, this property Y, which is an object. So again, everything in JavaScript is an object. So object X gets assigned the value of 2, object Y gets assigned a value of 2, and then this points to, and this is basically implicit in this situation, this is pointing to the window. And so we have over here too, this is our, remember our call, excuse me, remember the call stack I was talking about? So the word foo, or the function identifier, is on the call stack, because we're in the function. So that's on the call stack. Now watch this. When I tell the engine, okay, take a step forward. All right. See, food is popped off the call stack, and then we're out of the function. And then if we go to our console, we will see 4. So that's what we're doing when we create a function, when we declare a function, and when we execute a function.